hold up. Before we get into this next episode, I want to tell you about our virtual conference that's coming up on February 15th and February 22nd. We did it 2 Thursdays in a row this year because we wanted to make sure that the maximum amount of people could come for each day, since the lineup is just looking absolutely incredible, as you know we do. Let me name a few of the guests that we've got coming because it is worth talking about. We've got Jason Louis, we've got Shreya Shankar, we've got Dhruv, who is product applied AI at Uber. We've got Cameron Wolf, who's got an incredible podcast and he's director of AI at Rebuy Engine. We've got Lauren Lockridge, who is working at Google, also doing some product stuff. Oh, why is there so many product people here? Funny you should ask that, because we've got a whole AI product owners track along with an engineering track. And then, as we like to, we've got some hands-on workshops too. Let me just tell you some of these other names just for a moment, because we've got them coming and it is really cool. I haven't named any of the keynotes yet either, by the way. Go and check them out on your own. If you want, just go to home.MLOps.community and you'll see. But we've got Tunji, who's the lead researcher on the DeepSpeed project at Microsoft. We've got Holden, who is the open source engineer at Netflix. We've got Kai, who's leading the AI platform at Uber. You may have heard of it. It's called Michelangelo. Oh my gosh. We've got Fazan, who's product manager at LinkedIn. Jerry Louis, who created good old Llama Index. Oh, he's coming. We've got Matt Sharp, friend of the pod. Shreya Rajpal, the creator and CEO of Guardrails. Oh my gosh, the list goes on. There's 70 plus people that will be with us at this conference. So I hope to see you there. And now let's get into this podcast.
Hi, I'm Aayush. I'm a senior machine learning engineer at Pinterest, and I like to have my coffee, but I think for Indians, I've been not used to black coffee and stuff. I think Indians used to have some kind of, I would say, fake coffee. It's like a ready-to-make coffee. You add milk to it, and that's it. And I think that's the coffee I still like.
Welcome back to the one and only MLOps Community Podcast. I am your host, Dimitrios, and today we're talking with Aayush. This is what I would call a candid conversation. I appreciate everything about how honest and upfront Aayush was with his whole experience from 2018 till now, working on the ads team at Pinterest and bringing ML into their capabilities. He walked us through everything from the nascent ML project to the advancements that they've had. And I think one huge takeaway from my side was along the lines of how evolution happens and how evolution happens when you're at a big company like this. Because in 2018, they had to make decisions on what tech stack they were going to be using. And he talked about how the pipelining tool that they were using, they ended up having to get off of because it was something that was out of Twitter, and Twitter ended up not supporting it anymore. There was no company behind it. And they realized that this might not be the safest bet. So they got off of it and they had to evolve. And they did this many times throughout their journey, as he goes on to explain. And so I like looking at this evolution and how he breaks down the evolution in terms of what the ROI is every time they upgrade or they make the choice to, quote unquote, lift and shift. The thing that kept coming back to me was, is the juice worth the squeeze? That's one of the sayings that my dad used to always tell me, you're doing this, but I don't know if the juice is worth the squeeze on that. And he thinks about it in that way. He really thinks, okay, what's the ROI? If we're going to rip out some technology and make sure that we have a better technology, is it going to be worth it? And are we going to be regretful 2-3 months down the line or a year down the line because a potentially better technology has come out? So he talks through the decision making on that and what they did specifically for their ads optimization platform at Pinterest. Hope you enjoy this conversation. As always, if you do, share it with one friend. It will mean the world to me, and I will see you on the other side. What are you doing in India? You've been traveling the world. What is going on?
Yeah, I think Pinterest is very flexible as such. Like, I think they allow
Lucky
us
man.
to work like 90 days outside the country, and I thought it's a better time to enjoy that. Like, I've been, I think, out since November mid somewhere. I went
Wow.
to Europe for like 2 weeks, then been in India. I think this is a time where it's very auspicious to get married in India, and there are like a couple of my friends who are getting married. So I thought, let's maybe just stay back.
Oh, I thought you were going to tell me you were having a wedding.
Well, my wedding happened like 2 years ago, and
Oh,
so
well,
it's
congratulations.
been a
Belated congratulations.
yeah. Thanks so much. But yeah, I think Pinterest allows that, and I think there are not many companies right now. Like, there are many companies are calling people back, but I think Pinterest has been in a good spot there,
So
still
good.
allowing people to work remotely.
So when it comes to the Indian weddings, be honest with me. Have you been to one with an elephant yet?
Yes, just recently, last week. Yeah,
So
it's
wild.
fun. Yeah, it's fun. It's different than what used to be in America, but yeah, it's fun to be here.
Yeah, whenever my Indian friends are getting married in the US, I ask if they're going to have an elephant, and they're like, dude, you know how expensive that would be? That's just not in the cards right now.
Yeah,
So either I have the wrong friends or they need to go to India.
yeah. I think, yeah, it's a good time for India right now. It's like chiller than normal, although it's pretty hot if you go in the summers.
Yeah. So let's give people a little bit of background on what you're up to, what you've been doing, because you've been working at Pinterest, as you mentioned. You've been there for a while and you've been loving it. You haven't even changed ever. You haven't changed the team. So maybe we should start with that. Like, what's the deal with this team you're falling in love with?
Yeah, I think that's a good question. Like, I joined Pinterest in March of 2018. So I'm nearing 6 years. I've been on the same team. Like, initially, I never wanted to be on that team, I would say. Like, that's a funny part of it. Like, I was like, what, like, if I want to be like ads, like, I want ads ranking. Like, our job is to like rank ads and like show the best set of ads, correcting the advertisers to users. But I was like, this was the last thing that probably I wanted to do in 2018. But then luckily I ended up on this team, and I haven't changed the team ever. Like, it has so much to offer. There's so many things that you can do, both technically and also like as a product, like both from a technical and product standpoint. And it has satisfied, I would say, like what I was looking for in a job. And that's exciting.
Well, it seems like you've gotten to create a lot of different projects, right? Over your 8 years, or since 2018, I guess. My math is not so strong
6
right
years.
now.
6
years.
years.
I knew I was wrong, but I didn't want to tell myself how wrong I was. I wouldn't admit it to myself, but I guess it was pretty wrong. So the thing about it is that you've created a whole slew of projects when it comes to working with this team. And if it's all right with you, I would love to just break down these different projects and how you created them, how you went about designing them, and what you would do different now that we are in 2024. And obviously technology has advanced quite a bit. So ML in 2018 was a whole different beast than ML in 2020. And now we even call it AI. So it is in 2024, a whole different beast.
I think looking back, I think it has been a long journey, I would say, in machine learning. I think in 2018, like, I think you're not doing, like, we were doing like product building, like Pinterest was growing at a faster pace, and like advertising was something that Pinterest had started. I think we were around like pretty much like just building products, not caring that much about how to make the products better in terms of machine learning, but like just getting from 0 to 1. And one of the major projects that I worked on was like conversion optimization. And one thing about ads business is, like, you have like good leaders at Google and Facebook where okay, these are the things that work for them. And like it came up to the point that how do you make it work for Pinterest? Like, you have some direction, this is what you want to build, but how do you build is totally different at different companies depending on your users and your advertisers. So I think we knew that conversion business is big and it's going to work because it works for our competitors, and that's what the advertisers also care about. So what it is mostly about is like when you start building products, the simplistic product you would build is to like just like, can you deliver more of these ads to users? Then the next product would be, can you drive more clicks on these products so that like advertisers care more about clicks, not just people viewing it. And then the next step would be like, it's not only about clicks, but can you like get users to like convert more on those products, like buy something or they do like an add to cart on their website and all of those like complex things which advertisers care about. So
Yeah.
conversion product refers to the later product. So that's where like when I joined, the other two products were already built up in general. Like click product was there. We had that. Also the impression product, but conversion product was not there. So one thing in 2018, I would say it was not much machine learning. At that point, it's about how do you connect the pipelines together? How do you get through that? And I think one of the
What did the
major,
pipelines look like? What was it? What were
yeah,
you?
man, that's like totally different what that is today. But like in terms of like at that time, we were using like for basic ETLs, we were using like a cascading, like Scala cascading and scalding that came from Twitter. I think till maybe last 1.5 years, we were still relying on that kind of a legacy stuff. And I think over
Wow.
time, like we started removing like less of those like legacy technologies because I think both from like the technology was not getting updated, but also finding engineers who are familiar with that kind of toolkit is also gets harder because not many people are using. So one thing, at least over time, like Pinterest started moving that those Scala, like not Scala, but it was in Scala, but that cascading and scalding jobs to more like Spark based jobs, and I think that has something which back in 2018 was not that popular as such. So what we had in 2018 was probably what we started with. And
Well,
then,
this is fascinating that you mentioned that. Just to drop in a line real fast, is that it wasn't necessarily because of the pain that the engineers were feeling on the pipelines when they were using Scala jobs in whatever, like 2022 or 2023, when you said you replaced it, you ripped it out, or you slowly migrated over to Spark jobs. It was more because of the ability to find engineers that understood how this worked and were proficient in it. And then also, you had a little bit of fear, I can imagine, if Twitter wasn't keeping tabs on this project anymore and there wasn't really any support behind it. That's scary.
yeah, yeah, I think that's a good point. And I think both of those reasons, and also I think Spark provided a lot more flexibility, scalability, and scalding was not providing that over time. So I think over like things that worked in 2018 might not work in 2024, depending on progress that happens in the open source community specifically. And I think that fuels. And then migrations are hard, so you need to make a choice at some point, like whether it's worth to migrate or not.
Yeah.
At the, but
Yeah, the ROI of the migration too, that's a huge piece.
sometimes we move from like TensorFlow 1 to PyTorch, like we just changed the complete language in general because I think we thought like, and I think it's paying off pretty well today that we made that decision. But it's always hard to make those kind of decisions as such.
Yeah, in the moment, you're not quite sure. You're like, I think this is the right move, but we'll find out in 5 years.
Yeah, but I think I would say the key is to keep innovating and keep checking like what's working well, like in the industry, or like what's working well in the research community. And I think having systems that can migrate faster to new technologies as needed, I think that's the key to keep iterating faster.
Eh.
At some point, like in 2018, like we used to have a totally like a hybrid stack of machine learning. Like we used to train models, like deep learning was picking up for sure in recommendation systems, but at that scale, like the way we were doing was we don't used to do deep learning. Like deep learning started in 2018, like moving towards deep learning, but we used to have like an XGBoost based GBDTs, totally different language, trying to embed it into like a TensorFlow based logistic regression, totally different. And then embedding that again into a C++ library that we maintain for serving, which is like kind of like brittle systems. But that was what we had, I would say, at least till 2021, 20, like somewhere in 2022, to like slowly system started moving more towards more principled approaches of doing machine learning.
Yeah. Well, sorry, I totally took
Yeah,
you on a little bit of a sidebar on these pipelines, but get back to this conversion
yeah,
optimization. You were going for step 3, right? To actually get people to buy things when they clicked through an ad. So you did
yeah,
step 1, which was just showing people ads. You had step 2 also in there by the time you showed up in 2018, which was getting the right ads in front of people. And then it was your job to figure out how to get people to actually buy things once they clicked on the ads, or get the ads to people who were in a buying
yeah.
mood, I could say.
Yeah, I would say the latter, like how to identify people who are in a buying state, and also which buying state, like what particular ad would they buy in general. Like we have 10,000s of ads, you can show any, but like which one would be the best candidate. So as to like, and that improves, like finding that best candidate is important because it helps Pinterest to not show irrelevant ads. It helps advertisers to get value by showing the right set of ads to the right set of people. And like, I think all three needs to be balanced in some sense.
So how'd you go about doing this? What was your idea when you came through? You must have done something.
So I think if you look back, I think all of these problems like driving clicks, like driving conversions, like are very correlated to each other in general. Like it's just about, if you just look from a machine learning perspective, it's just about, okay, this is your training data set. If we show X to the user, do they buy or not? It's like a very simple, like a binary classification problem. In just in terms of a machine learning model, it's not very complicated. But then if you look at, you need to change your pipelines to get this data. Like before, when we were getting click data sets, everything is happening on site at Pinterest, and all of those kind of logs are owned by, like are governed by Pinterest architecture. But for conversions, this is not directly. You need to have like a integration with your third party providers. How you get that data, how do you transform that data, identify, and then pass it for training. So you had like more complex setups in your pipeline, very similar to like ETLs that you have, but you would have an additional pipeline, then making sure that this pipeline can connect to your model training. But model training is just one piece of it. But how do you like use that predictions of conversions in your, like when you're deciding on ads, then the other components that you need to build, then train your sales team to sell this product. Then there would be a lot of bugs. So you need a lot of visibility over it, like what's going wrong so that you can figure it out. And then it needs to be performant. Like you cannot have like because you're now comparing this product to a product which is driving more clicks. And you need to be better than that for sure. So it, at this point, it needs to come with some level of personalization. Like it can't just like come with some like random like previous priors or something, because that product would not work. So it has some baselines that you need to at least beat in general.
Well, it's in the name, even performance marketing, right? It has to be
Yeah.
performant. And the other piece that I'm thinking about is you had to do this real time, right? There wasn't like,
Yeah.
yeah, break that down.
So even in 18, like when I joined in 18, like I think ads, like one thing that keeps ads different than like non-ads is it needs to be real time, but also some of those signals need to be like computed like very real time, something like, because ads govern how much you are like spending, right? And then based on your predictions, you decide how much you want to charge your advertisers, and you don't want to overshoot their budgets as such. Since their budgets are fixed, like they would say, okay, only $100, they won't give you more than $100. You need to make sure this calculation is real time, that you're not overspending or underspending for sure. Like if they have $100, you would want to probably optimize for $100 that you want to spend. And then given the scale, Pinterest was still pretty big. Like all of these predictions, all of these models were making predictions in real time and having a lower latency too, like having like I think something around like 300 to 400 milliseconds, like in that range. Like you need to maintain that latency. So I think the modeling architectures were not that complex at that time. Coming to 2024, I think we started to hit the latency budgets now in general. Like models are becoming complex, and I think now, and also like we have this two-tiered kind of structures. You don't score all the ads, like it goes through like tiered, like a targeting, retrieval, and then ranking. So it's that controls the latency too.
today it's 2024, right? You set this up in 2018. What has changed? What now are you looking at? And you mentioned how you've migrated the pipelines, but what other things have evolved since?
Yeah, I think one thing in 2018, like I think machine learning was not that mature. Like you would probably plug in, like there's a lot of plugging that was happening in the system, many different like heterogeneous systems coming together. In 2024, I think that homogeneousness is coming in, like the entire pipeline is being trying to return in the same framework so that you can control more things. And one thing was in 2018, like that is much different than what we're doing today is like data preparation. Like there are like too many steps into preparing your data before it can be trained on a model. So these steps are we want to reduce these steps, like intermediate steps, and make sure that it's like one big data set, one model training. It's not like 15 different intermediary tables and monitoring them becomes harder. So that's a big shift. The other shift is, I would say, like in 2018, like since we are building up systems like traditional systems, like monitoring and visibility was missing in most of those systems. Like it was working and most of the time it would work pretty well, but like developing that kind of a monitoring to make sure that everything is right from your data preparation to your model health and like to your end-to-end pipeline health. I think those are things that are mostly taken secondary as you're building new products. Thirdly, I would say features like earlier used to be very like nested Swift objects. Like everyone would have flexibility to write something, they would write their own logic, and all teams would like do it in silos. Like they would write their own logics to do whatever they wanted to do, and then translating. And we had like a lot of different components, so you need to like translate from one language to another and all of those kind of things. So that is becoming standardized, and I think Pinterest has a blog if people want to read like MLN. But I think standardizing those processes, making feature engineering more, I would say, more standardized and shareable across different use cases. And I think that is fueling more faster iterations and making sure that you can iterate, but also share knowledge across like all the use cases at Pinterest.
And when you talk about monitoring, are you talking about monitoring on basically every level, like from the data flow level to the systems level to the model output level?
Yeah, today we are monitoring mostly everything in general, like from both the offline pipelines where our data is being prepared to our online pipelines, the way we are serving. And like for every model, we monitor their predictions, like whether they fall within a specific range over like a time, like weekend, like a time frame in general, like last week or like a day over day kind of variations. It like these are a lot of metrics you need to make sure then how you set up alerts, but like monitoring all of those things, monitoring your features, both how they are logged and used in your training pipelines versus also how they are being served, and all of those things is being continuously monitored and also alerted to make sure we can like catch things earlier on.
Yeah.
And we have more automated pipelines. If something is off, I think things would not get promoted and they would be stopped from being used. I think all of those monitoring is in place today to prevent many incidents that we used to have back earlier in general. So that has like reduced in that sense. But also it means now incidents are more complex than what it used to be. Like there could still be incidents, but I think they have become like more complex.
Yeah, so we were talking about this before we hit record, and it's interesting when it comes to Pinterest because even in 2018 when you joined, you had to be thinking about scale from day one, right? There was already a whole lot of users. And so how did that factor into the decisions that you were making?
Yeah, I think scale, like I think today Pinterest has about 480 like million active users. So I think scale is definitely important. And what it means is you cannot push anything to production without testing it. So definitely that is something that needs to take care. But also we need to make sure our systems are healthy to handle that scale in general. Like if you look at like also like in let's say in holiday periods, like the scale increases in general. Like in the other part of the years, like there might be like lower loads on your systems. But like how do you manage this load? So I think Pinterest on the server side, we do have like auto scalings and all of those impacts so that we can reduce like the usage of like our serving systems. When the scale is low, we can increase it when the scale is high. So those are handling some of those scales, but then also you need to make sure our modeling, like whatever the models we have, like earlier on when the number of users were lower, we can probably have simple models. We cannot afford to have more complex models either because the power that you might get from it might not be equivalent to the revenue that the model generates. So you need to make sure that your complexity is maintained with your business health, like it goes with your business or your goals in general. And thirdly, I would say like we need to make sure our pipelines, like over time, right? Back in there in 2018, our ETL pipelines could finish early because the scale was lower. But over time, your scale has increased, but you want to have the same like SLAs for your model trainings, and they're training every hour. So now you need to invest in optimizing your pipelines much better or much more than you were doing before. You could do anything like maybe make mistakes or like maybe do slower joins. Not your joins are not optimized, but now I think that becomes critical given the scale that your pipelines also need to be smarter than what it used to be before.
So you also went on to do a whole slew of other things, one of which is the video ads ranking. And talk to me how that was different than the conversion optimization, because it feels like there's some similarities there, but there's potentially a lot that was different.
So I think with conversion ads, I think it was like many of the components were there because you're dealing with the same assets like images in terms of like your content understanding. But when you move to videos, the way you understand content changes in general. It's no longer like a simple image. It's more about like series of images. So you need to invest at that. Like in terms of the model, it probably remains the same. It's now trying to predict instead of a conversion, like whether the user is going to view this product for, let's say, more than 2 seconds or 5 seconds. So the problem from a model standpoint remains the same, but how do you integrate this into your systems? Like, do you have a good understanding of the video, what this video is about? Like same features that you do on images. Like one simplistic thing to start this product is you can just say that, okay, for this video, you have a representative image that represents this video, and that is what you're going to use. So those kind of like that, by just doing that, you can just treat this video as an image, and then everything can just flow through as what you used to have before. But to make it performant, you then slowly need to keep adding more kind of features on the video understanding, and then can you make those features better, which is different than images. So then you need to be aware that this only impacts the video optimization. You cannot reuse these kind of like new features across the stack. So that is something then you need to balance between like how much is the effort to do that versus like what's the potential gain that you would get from that.
I like how you come back to that idea. You said it before in the last question, and now you're saying it again, and I want to highlight it because I feel like it's very important. That trade-off of the effort to basically, is the juice worth the squeeze? Is it worth it for me to put all this time, energy, and effort into this in order to get how much of a payoff? And how can you, I guess my big question is, how can you quantify that payoff before you've actually done the effort and know about it?
So I think there are two things I would say. One thing is the systems ready to do that? Like, do you have systems in place where you can do that easily, or versus it's time that you need to optimize your systems to do that? For example, if I want to add video features, if the stack is too complicated, like let's say, like back in 2018, the way we used to do that was we used to have a separate pipeline, like for creating our training data sets, and that was based on if issue an ad to the user, we'll log all the features that we used to have at that particular instance because everything was real time. And we didn't have a notion of, let's say, feature backfilling, or we don't have a notion to add features historically back into your data set. Because of that, if you need to train models, like models for training on, let's say, 6 months of data or like 3 months of data, you need to wait for 3 months before you added a feature into the system. Now that delays you by 3 months. So at that point, I think we started investing in improving our backfill capacities in general. Like we can do feature iterations faster. Like Because if you thought this feature is going to work and it doesn't work, you wasted 3 months thinking that it would work, and then it just slows down everything. So if systems are not ready, I think that's one factor. Like, how much does it take to, like, because you can think about new things, but if the systems are not ready, you cannot go about doing that, and that reduces the return that you would get. Like, it's 3 months delayed. Other than that, I think it's mostly intuitions at time. Like, if you do things simple, there would be lower risk in general. Like, if you start moving with, like, because I think there are a ton of research that might go around, and you might think about good complex ideas that might, okay, this sounds fancy, but then I think the payoffs, if you haven't done the simple things, is like lower in that sense, because it's more complex to build those complex fancy things out in general, because there are more chances of having bugs in the system. So having, like, moving from like a simplistic thing to more complex, I think that reduces a lot of the, like, risk, and also the product can keep growing iteratively over that.
Okay, so if I'm understanding it correctly, it is figuring out what the easiest and most simple way to do something is until you bump up against some kind of a bottleneck or some pain that you realize, oh, this is really causing us problems. Let's now figure out how we can alleviate that pain, that specific pain, whether it is the feature engineering or waiting for a model to train 3 months later. And that must have been just painful, trying to wait 3 months to know, is this feature actually useful? And then you don't want to do anything else special because you want to have, like, okay, I updated this feature, and so let's see if that actually works. And so then potentially you're constrained for like 3 months while it's training. And so you're working with that, but also you're waiting. It almost feels like you're knowing that if we wait and see, technology in a way is going to kind of catch up with us. So the longer that we can abstain from getting things too complex, we can leverage time to be on our side so that when we do go complex, we have better tools available.
Yeah, I think that's a better way to put it. Thanks for doing that. But I think having places where you can evaluate moving to like a better infrastructure or like better tooling, I think the tooling is the key in general, like building that tooling. Like, because when you move fast, you might not have the tooling, and that bites you back later in general.
Yeah, because you've made those decisions and they're potentially, I'm not going to say irreversible, but it's a lot harder to rip out the technology than it is to just wait
Yeah.
and choose a different one in a month or two.
Yeah, and one example I can share, like, we were at like this hybrid system where we are serving in C++, because that system touches users directly, like it's in your like critical path of serving. Moving that system was pretty hard in general. Like, many teams, like, they had to spend multiple quarters to just, because you need to move, and then you need to move by making sure you're still improving your business metrics. It's not that you stop all the work. It needs to move in parallel. Like, it's something like you want to change like wings on your plane, but the plane needs to keep flying. Like, you need to change that in the flights. I think that is something, having the right tooling and having like right prioritization helps at that point. But eventually you need to, like, the thing is, it took, I would say, at least 2 years somewhere there to move from that kind of a hybrid system, but it's paying off now today. So having that future mindset to know, okay, like, this definitely is a bottleneck and you can't go further in this direction without like changing it so that you can be better in the future. I think that kind of calculation is important at some points. Like, I know, like, there are still companies who have such hybrid system. They're like, okay, we want to move, but it's harder to move, and they don't make the switch. But I think it just slows you down in general for future.
And do you have any advice for those migrations and how to do them gracefully?
So I think, one, it's commitment for sure. Like, need to be committed. Like, things might not look like very, very beautiful in the beginning. So having that commitment from top down that we're committed to do this. The other thing is building the right tooling. It's not about like, okay, just changing that, like, the frameworks, but if you have the right tooling to make sure that between A and B, the new systems, like, everything is probably similar. I think that is something investing in the tooling is important to make sure that you can cover bugs earlier on than later. Because when you're doing these kind of system migrations, like specifically for these large scale models, like even if one feature is not being translated fine, like you would have like systems would just break and you would not know what's going on. But can you go back in your systems and like replay what happened in two of these systems and see like where they diverged? And I think having that kind of understanding helps to migrate faster. And also sometimes getting all teams aligned is better. Like getting one or like major teams aligned is better, because you don't want to have this migration as a chasing target always, because if you keep iterating and improving the older system, you need to make sure that at least there's some consensus, like when there's like priority shift that needs to happen just to the migration at that point, because otherwise the post will keep shifting and that makes it very hard for everyone to move out. But you want that kind of period to be very small in general. You don't want it to be like 4 months that nothing goes in, you're just migrating. But you want to reduce the time to that kind of like shift system migration. That's why.
Yeah, because it feels like the longer that you don't finish, the more chances that you have for second guessing yourself or trying to implement something else new and saying, oh, well, actually this might be better. But if you have it as a short window of time, then that shorter window of time is not going to allow you to add all these curveballs into the project.
Totally. And because I think the migrations is always on the infrastructure side. You don't see the benefits when you're doing that, but it comes out eventually. So I think it needs a bit of support to make it happen generally.
The other thing that's coming through my mind really is going back to that idea that you were talking about in the beginning when you said the technology that we had chosen was no longer being supported. So it was some open source technology that didn't have anybody backing it, and let alone a company, right? And then it was becoming harder to find people that understood this technology and could code in whatever this language or could use these frameworks. And so as you're thinking about migrating and making a new design decision, how are you making sure that that very same thing will not just happen again in 4 years? Or do you take that as, you know what, in 4 years, we'll probably be looking at this again and we need to do it again. But for now, the best thing that we have is XYZ.
Yeah, I would say like it's always a continual looking forward. Like you would say, okay, for now, this is the best thing. Because I think specifically in machine learning and also other software engineering, I think things are moving pretty fast. Machine learning is moving pretty fast. Even right now, I think things are moving pretty. Like back in 18, TensorFlow was the go-to production system. Like everyone in the industry who are productionizing systems, okay, TensorFlow is the best system. But as we were in TensorFlow 1, TensorFlow 2 came in. That was a total surprise because you can't go from 1 to 2 directly. It's not like you can have that version upgrade seamlessly. And that was a point when Pinterest decided to do like TensorFlow 2 versus Pytorch, like what makes sense. And then what we did around that time was something, we had a bunch of engineers working on translating like a small piece of modeling code from 1 to 2. A bunch of engineers translate, and those same engineers translating it also into Pytorch to see what their experience was. And after all of those considerations, like developer feedbacks and stuff, we decided, okay, PyTorch makes sense. And that was a totally, like, we moved away from TensorFlow and moved to PyTorch. And I think it's paving off pretty well today. I think we see that industry or like academia definitely is more PyTorch friendly today. So keep evaluating, I would say, in that sense, for over like a longer time period. I think it was, yeah.
Was there ever the idea of trying to support both of them? Did that conversation come up?
I think from a machine learning, so I think the thing is from a machine learning platform perspective, supporting less languages is better for them because then they can focus on particular language more. But I think it depends. Like there are few use cases who were like, no, everything is in TensorFlow. We want to do TensorFlow, but like given that TensorFlow 2 was totally different than TensorFlow 1, you need to move to 2. So I think that made it easier. But I think over time, I would say like depending on business use cases that exist, like they might have like a language decision. But luckily for PyTorch at least, I think things were favorable that most teams agreed. And once major teams in the ecosystem agree, I think the other teams also need to eventually agree, because I think that becomes the more iterated. Because at day zero, they might look same, but as people start to work on those systems, you would have more functionalities, you would have more things built up, which you can reuse for easier and cheaper if you're stuck with like the framework that everyone is using.
Man, TensorFlow 2.0, the beginning of the end. That is so wild to think about, think back on the history of how that played out.
Yeah, I think depends. I think some companies are still using it, so I don't think it's
Oh, for
ending.
sure.
But yeah, but at least at Pinterest for today, I think it's not there.
Yeah, that's wild. So now talk me through what things you would have done differently, knowing what you know now. And I don't want to say like, oh yeah, live your life with a little bit of regret, but for the rest of us that potentially are building systems and thinking through building these systems, what are some things that you know now that you would have done differently?
Yeah, I think one thing I would say, like when we were in 2018, I think improving the way you train your models, and also I would say like in 2018, like training models were not very easy. Like you need to like copy some code, check in that code, like duplicate copy some code, check in the code, change some parameters, and
Ugh.
that is probably just slows down. I know like many companies have a similar thing even today. Like you cannot easily train multiple different models. Like having that flexibility, like Pinterest had like an internal system called as EasyFlow that was developed. I think that was pretty useful. So that now if you want to change things, can you do like a no code version of it, and you can just change parameters, change things. Don't need to wait for check-in. I think that was something if we had earlier on would have been useful. The other thing I would say, I think it's easy to say that, but I think the thing is, can we remove the hybrid systems that we had, like training in a different language, serving in a different language? But I think it also depends, because I think that helped us to go to market faster, because that was what existed in 16s and 15s to get to the market, because other systems are not mature. But if Pytorch was more mature in 15, 16, I think we could have saved a lot of time in those migrations. So it's easy to say now, but I think practically, I think it might not have been the case, because I think those things are also developing, I would say. So in that sense, yeah. I think C++ is one language. I think machine learning engineers you don't have that many machine learning engineers who understand C++ still, I would say. So I think that's where where like, I think in serving systems, yes, there are many, like you can find people, but not everyone who is in academia doing machine learning would be comfortable doing C++. I think that's something, I don't know. Yeah.
I was expecting you to say C++ is a language that I never want to touch again in my life.
Yeah. But I think for low latency serving, I think you still need people to know that, to pull things off in general. But I think that's something is reducing over time.
Yeah. Yeah. So then now that we are in 2024, and as you look ahead, I mean, on all of these different projects or whatever you're working on these days, what are some things that you are interested in implementing in your stack, or not even implementing in your stack, just things that are getting you excited?
So I think the thing I would say, like when we moved from GBDTs to like, let's say neural networks, I think we knew, okay, the first migration we did from GBDTs to neural network was kind of neutralish. Everyone would think that, okay, bringing neural networks, you'll get like magic out of it. It was totally like neutralish. It was kind of building the backbone of what we are doing. But I would say like advancements that are happening in like language processing, where you have like a lot of sequence of words coming in. I think the same kind of advancements is happening in recommendation systems, where you have, instead of words, you have like interactions that the user is doing, and those sequence modeling techniques are becoming complex. And that's where I feel like much excited. Like even like things like NLP is like kind of influencing like recommendation systems. So at least in the back end, I would say like things are coming together in general. Like those transformers are in recommendation systems. Transformers are in your computer vision system. So they're not that separated out industries. Like the use cases are different, but I think those techniques are getting getting adopted widely, even in recommendation systems. So that is exciting to see how things are coming closer in that sense, and how that research is useful even for our models. The other thing is, I mentioned before that we used to have many intermediate systems, which slows you down. Let's say if you want to train a new sampling strategy or do different sampling, it was harder. But I think we are moving into integrating most of our systems with Ray to do like in trainer samplings and moving things more flexibly into your model training like flows. I think that is pretty exciting because now you can do much more things at like a faster velocity and not being bottlenecked by your frameworks.
Talk to me about this idea of transformers for basically for the ad rankings, and because I think I understand it, but I want to hear you dive into that a little bit more.
Yeah, so I think there are two ways you can think about transformers in general. So how these ranking models work is you have set of features that represent your users, some set of features that represent your content or pin at Pinterest, and some set of features that represent their kind of interactions that you're having with them. So typically these recommendation models would have a way to learn these interactions, like learn these feature interactions among themselves as part of the model architecture. And there are things like crossings or like deep cross networks and other kind of research there. So one way you can also think as transformer is just kind of learning how these features interact with each other. There's no positional kind of system here, but like just a transformer encoder can be used as a feature interaction layer, trying to learn whether feature A is related to feature B and by what magnitude. So that's one way. The other way transformers are being used is users, when they come to the platform, they can interact with a lot of pins. They might click on some pins, they might hide some pins, save some pins. So this is like a sequence of interactions. You can think about like user journey. And if you look at like natural language processing, you can think this is like a sentence of words, and you can
Yeah, that's
translate
wild.
into same way to say that what is the next probable word that would come in this sentence, and say that
That's so wild.
if this is the sequence, what is the next action, or like what's the next content that you might interact with? Just model it very similar to what is in the text processing domain, and try to, and that's what recommendation system is. Like you have seen everything, what is the next you want to see? And I think transformer and LP comes very close to that. And transformer is building block to make that kind of like prediction or setup for training. And that's where I think most of the wins are coming from today, to understand the user better and make it more personalized.
Yeah, the sequence and mapping out a sequence and then trying to decide what the next token is, like you get with
Yep.
ChatGPT, or
Yep.
what the next token is as far as what ad you should show. That is incredible. And that's what I thought I was understanding. And I know I've seen a few papers on it. I just wanted to make sure that I was
Yeah,
getting it.
I think things are coming. Like I think that's good thing about machine learning. You take motivation from somewhere, you combine it together, and it mostly works in your domain too. Like it's probably just getting motivations and trying those things out.
So the one thing that I have to ask about is because recommendation systems, and you were saying it earlier, like there is a very stringent need for things to be fast.
Yeah.
Transformers aren't necessarily known for being
Yeah.
fast. How do you look at those two things and how do they coexist?
Yeah. So I think as we move to transformers, I think we started hitting our latency budgets in general because they are not that fast. One thing is, before transformers, we were just doing CPU servings. We had to move to like GPU serving to unlock the similar kind of latencies. One thing is it comes at higher cost, like, but if you're personalizing better, you can recover some of that cost. Like that's one factor. But I think at some point you'll also hit the ceiling where you cannot have the same kind of personalization unblocked that you might get by increasing infrastructure. So I think things like you quantization for serving, you're reducing the model complexity. In terms of sequencing, depending on how much benefit you get, you can control the length of the sequence. Then you can optimize and make your sequence, because sequence length contributes directly to how much cost you would have, because the larger
Yeah.
it is, the higher the cost it would be. Then you can make the sequence more smarter by not having many similar content in that sequence. You can represent like many similar content with just like a representative content from that. So you can reduce your sequence and be more smarter with your sequence to reduce that length in general. Thirdly, you can start to put some of this processing into your offline systems, like reducing the amount of things that you compute online. Because some of the longer sequences beyond, let's say, 1 month or somewhere there can also be computed offline and indexed into your system, and you can just reference that on the fly when you're serving the model. So some of those kind of more complexities you can address and add into your system in that
Okay,
sense.
again, going back to your idea earlier, because it sounds like you are definitely not just hitting an OpenAI API. You've got a whole lot of stuff going on behind the scenes with your own models that have been trained on these sequences, and you're doing some pretty nice optimization to make sure that they're not too expensive and they're not too slow.
Yeah, that's totally true.
So going back to the idea we were talking about before on the complexity side and staying simple and then getting complex, I'm thinking like it feels like it's not possible to do this by just going out and using one of these LLM provider APIs because of the latency requirements that you have.
Yeah, I think it's not possible. I think for that purpose, Pinterest definitely uses, let's say, Pytorch for our training, but our serving systems are built in-house to do all these kind of optimizations that you might not get off the shelves. So our serving system definitely is much more complex in that sense to handle those things. And I think it takes a lot of time to build those systems. I would say like the time to build might be reduced right now because of all the advancements that are there, but like for Pinterest, like we moved to, let's say, deep learning based systems in like 2020. Then we spent a lot of time in like making our systems monitoring better around that time. I think sequences started coming somewhere in like 2022 to 2023. So we have like, even when you're making these sequences, and like when we added the first sequence, it was not transformer based sequence. It was very simple, like attention based models, like no transformer in there. And then we started slowly making sure our systems can catch up with the kind of modeling techniques we want to do. And that's where I think right now, I think we are at a stage that we can invest in more complex than what we were doing last year.
It's incredible, dude. Well, this has been fascinating getting to pick your brain about all this. I really enjoy how you think of things and how open you are to all the learnings you've had over the years. It's super cool to see. And thanks for coming on here.
Yeah, thanks for inviting, and also thanks for others for listening so far.